Okay, oops. In the last video, I made an error where I seem to have lost track of where theta is, and I apologize for that error. I was thinking about it. Where will the theta be? So it's easy to work this out. That the angle I had proposed, theta, to be the angle between the plane of the door and the force. Well, that doesn't hold true, and that's where my error lay. Theta obviously cannot be there because the cos of theta, right, should give us the clue for this. Again, we take the extreme situation. If the force were to act at that angle, right, and if therefore the theta will be equal to 0 degrees in that case, then the component of the force that is helping us to create the moment, to create the torque in that direction would have to be cos of 0, f cos 0 degrees. Okay, and what is cos 0 degrees? I'll go to the screen share, right? Cos 0 degrees would be cos 0 is equal to 1. So it leads us to the absurd situation, which will be f times 1, which will be equal to f. That means the entire component of the force vector will be contributing towards the torque. And that, in this case, is obviously wrong, because if you push the door in that direction, you can imagine that there will be no torque possible. Okay, so therefore my assumption that torque is the theta is there was incorrect. So what is theta? Well, if it is not to the horizontal, then it must be to the vertical. So the angle of theta would have to be here. This would have to be theta. And if that is theta, then you come to the extreme situation where you're looking at a force acting along this line. If the force were acting in this direction, then theta is equal to 0, and then f cos 0 will equal to f, because cos 0 is equal to 1, which means that all of the force will then contribute towards the torque, which then makes sense. And therefore, this is theta. Then the correction that I made in the rest of the video makes perfect sense. Sorry for the mistake.